Right, so we're going to be solving the last question on the 2021 AQA paper. It's to do with the rates of changes, and basically the way that we can solve this is we've got the first sentence here. It says volume spherical bubble increasing at constant rate. So this word constant basically means well, it's constant. Yeah, it's constant. So we don't really need anything else apart from just to write dv over dt, which is the rate of change of the volume, equals k1, just a constant. Then second step, read what it wants. Read what the question wants now. So show that the rate of increase of the radius, so that's dr over dt, of the bubble is inversely proportional to r squared. So we want proportional to 1 over r squared. Right. So, and we're given this equation of a volume of a sphere. So that's just common knowledge though. So the first step would most likely be, we've got a v equals equation here. We're going to have to set out what we want to get this dr over dt. So I think, okay, it won't go back. Okay, there we go. dr over dt. We can make this v equals into a dv over dr by just differentiating this right here. So we've got dv over dr, dv over dt. We can already see some things cancelling right here. This is actually quite simple. dv over dt times by 1 over this. So it'd just be dr over dv. Right there. And obviously these two cancel, and then you get dr over dt. Right. So let's get started then. I think the first thing we can do is actually figure out what dv over dr equals. That's very simple power rule right there with differentiation. Literally just bring down the 3 from the power. It cancels out with this 3 right here in the fraction, and you get 4 pi r squared now, because you minus 1 off the power as well. Then we've figured out this k right here from literally just reading the question, saying at a constant rate. So we'll just sub everything back into this equation that we figured out here. dv over dt, k times by dr over dv. So that's very simple. You just flip this equation, make it into a 1 over. So now we want, that's k1. Want this, and as you can see, it's already looking pretty decent. We've got this r squared right here on the bottom. We've also got this r squared right here on the bottom. So what I do, you can probably get away with that 4 marks, but what I do is I change this k1 times this other constant right here, 1 over 4 pi, into just k2 times 1 over r squared, and then make it just k2 over r squared. And then there you go. That's 4 marks. Easy peasy lemon squeezy.